Okay, hello, good day. Welcome to another episode of Mathematics with Mosaic Tutors in Pidgin. So today we'll be looking at factorization of binomials. We'll look at factorization of binomials. Now, before I explain that make I quickly mention say wetin we wan do now like the reverse or the opposite of what we don't do the last two videos. So if you want to know what we talk about, now expansion of algebraic terms now we do. So you feel check other videos to look into one. Now wetin this one really mean for Pidgin? Factorization of binomials, wetin e mean? E dey very easy, now straight to the point. To factorize means simply to put into brackets, you understand, something dey too big, so you wan make am less difficult by putting it into a bracket. Na simply wetin mean be that. What about binomials? Now last week, or no, the last two videos we learn say algebraic terms or anything wey be algebraic numbers and so on, na something wey be say e be number and e get letter at the same time. Example 5a, 3b, 6e, 10f and so on. So binomial na when you get two algebraic terms. You get 5a, you get 3e, so you can say 5a plus 3e, e don become binomial. Bi means two, so when you get two algebraic terms, you go call am binomial expression, or you just call them binomials. So now we dey learn how to factorize binomials, which means we dey learn how to put into brackets some letters wey get numbers, two group of letters wey get numbers. E dey very easy, no dey complex. Now before we go into factorization itself, we need to learn just one like a ladder wey go lead us to that factorization. E dey very important also, and that is HCF. I know say most of us don do HCF and e dey very easy. Now HCF, when it comes to binomial, dey a little bit different from the normal one. We can go through the normal stage as well, but e go dey too long, you understand, because you know this is just one of the road you will pass to go to your calculation, so you know we won't waste too much time. So we'll look at a very quick way, a short way of we find HCF of numbers. Then when we find the HCF of that number, that HCF we don't get, now we go use for our binomials. So make we look at some example. We go start with only letters first. So if I get AY plus AX, if I get these two and they say make I expand them, they say make I factorize them. Before I go factorize, it is very important for me to know wetin be the HCF first. So with this in mind now, we will go into HCF. So wetin be HCF of AY and AX? HCF of AY and AX. For this one, it is very easy. HCF just means say wetin you dey see here, wey you also dey see for here. Na that thing na be HCF. E dey very easy when they are just letters. You dey see am for here, you also dey see am for here. Wetin be that thing? You dey see A here, you also dey see A here. So A na the HCF of these two. So you get just A. Now let's go forward a little. If you get A square Y and A square X, now wetin be the HCF? In other words, wetin you dey see for here wey you also dey see for here will be the same thing. E no dey easy, e no dey difficult. I mean, you dey see A square here, you also dey see A square here. So the answer na A square. Now we also wan go a little bit further. Now I come get A cube Y and this one come remain A square X. So this one na A cube, A raised to power 3, A 3 places. This one na A square, A raised to power 2, A 2 places. This is Y, this is X. Wetin I dey see for here, where I also dey see for here. Or like they talk am for English, wetin dey common between these two things. So for us to know wetin dey common, just for the sake of this particular example, we go break these two down. When we break these two down, we go look at wetin dey common and how many times e dey common. Shey you understand? So we go break this one down. A 3 places means A times A times A, then we come get times Y. Why this one na A times A, only 2 places, they come get times X. If you look here, you go see 3A for here. If you look here, you go see 2A. Now, if you look here, 2A dey here, but 3 dey here. But the common thing between them is say they get 2A. Why is they common? Because before you go see 3, you need to see 2 first. If we say 1A, they common. We know they correct because if we common 1A, you go see they see another A for here again. If you common 1A, you go see they see another A again. So 2A still there, A still there. So you never collect everything where they common. But if you collect 2 for here, and you collect 2 for here, you don't collect everything where they common. Because wetin go remain for here na AX, and wetin go remain for here na only X. In other words, e no dey important for you to pick only wetin dey common, but how many times that thing dey common dey very very important. So this one na 2, this na also 2. If you remove these 2, then you go dey have, and this 2 means A raised to power 2. So which means wetin dey common between these 2 na A raised to power 2. Very very straight to the point. Now we wan come include letters, numbers I mean. When we include numbers, we treat the numbers first, then we go to the letters. So make we include numbers. So we'll start with easy number. So make we say we look for the HCF of 4A and 2A. We look for the HCF of 4A and 2A. So the first thing we do is we start with the numbers first. When we finish with the numbers, we fit come go to the letters. Now, the numbers are 4 and 2. So in this case, you just ask yourself one question. Wetin be the biggest number we fit divide these two numbers? The biggest number. But the number must not be past their 2. The biggest number will be say, if I can divide this one, I will get my answer, no remainder. If I divide this one, I will also get my answer, no remainder. If you look well, 1 fit divide the 2 of them, but 1 will be the biggest number. 2 fit divide the 2 of them, and 2 and the biggest number we fit divide these 2. Because if 2 go here, the answer is 2. If 2 go here, the answer is 1. So for the side of the numbers, we have 2. After getting 2 on this side, the next one you look at now the aspect of the letters. Now A dey here, A dey here. They don't need to tell you 2 times say na A, then they common between the 2 of them. Why? Because if they see A here and you also they see A from here, so you just put A. So my answer, simple, 2A. So 2A na the HCF of these 2. Make we go front, we'll look at other numbers. Now let's imagine we can get 9AB and 15A. 9AB and 15A. Now for these 2 terms, the first thing you look at na the number. So if you look at the part of the numbers 9 and 15, what will be the biggest number we fit divide 9? We also fit divide 15. If you think well, you go know say na 3. 2 no fit divide 9, 2 no fit divide 15. So you go say na 3. Then when you get 3, you go on to the letter aspects. Wetin dey here, we also dey here. A dey here, A dey here. B dey here, but B no dey here. So B no even dey the question. The answer na A. So you put A for here. And your answer na 3A. Now we look at a more complex set of numbers. So let's say you get 12x squared y and you get 30xy. 12x squared y, 30xy. We'll start with the number first. What will be the biggest number if you divide 12? We also fit divide 30. We'll start with 2. 2 fit divide 12. Remember no go dey. If you also divide 30, the remainder no go there. So if you write am somewhere 2, because we no know if 2 na the biggest number. Wetin again fit divide am? 3. 3 fit divide 12, no remainder. 3 fit divide 30, no remainder. So you also add 3, now you don get another big number. Let's think again. What else? 6. If we talk about 4, 4 fit divide 12, but 4 no fit divide 30, so 4 no dey the question. 5 no fit divide 12, but e fit divide 30. We need wetin go fit divide the two of them. 6 fit divide 12, and e fit divide 30. So you also pick 6. 7 no fit divide their 2. 8 no fit divide their 2. 9 no fit divide their 2. 10 no way. 11 no way. 12 go only divide this one, you no go divide this one. And when you start from 13, you don comot 12 for the question. Because any number wey big pass 12 no fit divide 12 again. So these are the three numbers wey fit divide 12 and 30. And wetin be the biggest among them? 6 na be the biggest. So wetin the common factor between 12 and 30 na 6. Now make we go to the letters. You get x square, you get x y. Make we look at the part of x first. Wetin dey common between this x square and this xy? If you remember that time, x square means 2x, x square means 1x. If you say na 2x dey common, na only 1x dey here, so 2x no dey common. Na only 1 because na 1 dey here. So you just take 1 for here, take 1 for here. So na 1x dey common. So you get x. You dey see y here, you dey see y for here also. So you also add y, which give us the answer 6. Okay, so having the knowledge of HCF now, we fit come move into factorization itself. So we'll comot HCF for the question. So now we fit move into factorization itself. But don't forget, we will need HCF as well to be able to complete this. So let's move to example number 1. For number 1, you get 10a plus 15ax. Now to solve a question like this, since we thought say you dey try put something inside brackets, it takes a particular format. So now you write that format here. That format now, something go dey outside, you open your brackets, something go dey inside, you put a sign here, either plus or minus. Make we put plus, depending on the sign wey dey for here or the signs wey they are giving. Then another thing go dey for here, then you close your bracket. This is the format this one takes. If you remember when we dey do expansion, if you check the video then, when you do expansion, if you want get this one back, like just to do like this and do like this, you go get these two back. So now to get this one, the one we dey for outside, is very very simple. This one we dey for outside, na the HCF of these two. Now to get these two wey dey for inside, divide the HCF by this one, you get this one. Divide the HCF by this one, you get this one. Very simple logic. So now this format now will give us. But the HCF itself must always be outside. The HCF must always be outside. So now with this scope now, if we go to number 1. So for your number 1, you get 10a, 15a, x. You start with the numbers. Wetin dey common between these two? 10 and 15, wetin dey common? Wetin fit divide 2? Wetin fit divide 15? Wey remainder no go dey. The same number wey be say na the highest. If you look at 2 fit divide 10, but you no fit divide 15. 3 fit divide 15, you no fit divide 10. 4 no fit divide any one of them. 5 fit divide 10, you fit also divide 15. And no other number before 10 fit divide these ones again. So the answer will be 5. Now only 5 fit go into the three of them will be the highest number. So you get 5. Now going to the letter, A dey here, AX dey here. Wetin you dey see for here, we dey see for here too. Now only A, nothing else again. Then after you write this, now you know say you don't get your HCF. After getting your HCF, as you just open your brackets. So for your bracket, one term go dey for here, you put your sign, another term go dey for here. To get this one go dey for here, this one divided by this one. Now to divide no dey complex. Put this one for up, 10a over, put this one for down, 5a. Now to divide, anything will be the same thing, cancel them first. 5 here, 1, 5 here, 2. My answer is everything 2. So you put 2 for here, you put your plus. You do the same thing to this 15 also. Do the same thing to 15 also. You divide 15 by this. So you get 15ax over 5a. Anything wey dey common cancel am. So a cancel a. Wetin remain? Nothing. X no dey here, so no fit cancel x. So 5 here 1, 5 here 3. So wetin be the answer? You get 3 and you get x for here. So that's 3x. So this na your answer. You don factorize this term wey dey for here. To get back to your answer, e dey very easy. If you remember the step of expansion, like I mentioned, you just carry this one, multiply this one, carry this one, multiply this one. You get these two back. 5a times 2 will give you 10a. 5a times 3x will give you 15sy. 3 times 5, 15. A times 1a, 1 times x. So you will get the same thing wey dey for here back. So the process is just very easy. We could do the other examples. Now for number 2, you get 12y plus 8z. 12y plus 8z. So you go through the same method. Wetin dey common between these two of them? 2 dey common. 2 fit divide 12, 2 fit divide 8, but 2 no be the highest. 3 no fit divide 12, no fit divide this one. 4 fit divide 12, e also fit divide 8. 5 no fit, 6 no fit, 7 no fit, 8 fit only divide 8, e no fit divide 15. And so since you don reach 8, you no fit continue again. So our answer na 4. Na only 4 be the highest number wey fit divide 8 and 12. So for number, you write 4. Y dey here, Z dey here. Wetin dey common between them? Nothing. You dey see y for here, but you no dey see am for here. You dey see z for here, you no dey see am for here. So there is nothing common between them. So na only 4 na be our HCF. Then you open your brackets. For your bracket now, you divide this by this, you divide this by this. So you have 12y over 4. Y no dey for that, so no fit cancel y. 4 here 1, 4 here 3. So you get 3y. So you write 3y plus, do the same thing with this other side too. This is 8z over 4. Z no dey here, so you no fit cancel z. 4 here 1, 4 here 2, 2z. So you get 2z. If you don't know if the answer is correct, multiply this, you will get these 2 back, and you will know if your answer is correct. We will move to number 3. Number 3, get 4n squared minus 2n. Start with the number. Wetin dey common between these two? That is, which number fit divide 2 and 4? Wey remain no go dey. Na only 2. Then what about the letters? You get n squared, that means you get 2n for here. You get 1n for here. But you no get 2n for here, so you no fit use 2n. You use only 1n, because if you comot 1n here, you also get 1n for here. So you put n. Then you open your bracket now. You divide this by this. So this na 4n squared over 2n. For the sake of emphasis, I want to expand this one so you go understand. Normally, I will use this n to cancel these 2 for all, but may it not be like magic. You will get 4. This n, like I talked before, means n times n. So you have times n times n. So you get 2n here, which means n raised to the power 2. Then all over 2 times n. 2n means n times 2 times n. 4n means 4 times n. So you get something like this. So if you now divide, 1n cancel 1n. This n will cancel again because no n again for it to cancel. So it will remain there. They won't fight. This one then be 2. So these 2 don't beat themselves to death. And only this one that remain and you no go cancel. So 2, 1, 2 will cancel 2. Give you 3 cancel 4 to give you 2. So you get 2 with 1n for here. So the answer is 2n. So when you multiply this one, you are going to get 2n. 2 times 2 4, n times n squared. This time we did here, now minus. Then you have 2n divided by 2n. So you have 2n over 2n. N cancel n. 1 here, 1. 1 here, 1. So the answer now 1. 1 over 1 now always equals 1. So you have 1 here. You close your bracket. If you expand this one, you will also still get the same thing you get for up. We will look at the last example. Last example, which is number 4. You get 5a squared minus 2ax. 5a squared minus 2ax. What is the common between these two numbers? So make I quickly add, say, no be every time you will see something wey dey common between the numbers. In this case now, nothing dey common between them. Why? Because 2 fit go in 2, you no fit go in 5. 3 no fit go in any of them. 4 no fit go in any of them. 5 fit only go in 5, you no fit go in 2. So they no get anything in common. Leave am like that. Move to the letter side. If they no get anything in common, no give them wetin they no want. Since they no get anything in common, you leave them. If I get dog, you get dog, then we get dog in common. But if I no get dog, my friends you no get dog, you no fit force dog give us because we don't have it, and so we no get anything in common. The same thing, they no get anything in common, so you no force am. So you come to this other side, letter side. 2 dey here, 1 dey here. 2a dey here, 1a dey here. So they get 1a in common. So you put a. X no dey, x no dey. So the only thing wey these two things get in common na only a. Because na only a you fit see for here, also see for here. The number no dey common, you no dey see x for here. So you just leave am, then you open your bracket. Divide this one by this one. So you get 5a squared over a. If you break this one down, this is 5 times a times a all over a. This a cancel this a. Wetin remain for here? 5a. So you put your 5a inside the bracket. The sign wey dey here na minus. This one also divide this one. That is 2ax over a. A cancel a. Wetin remain? 2x. So you put your 2x and you close your bracket. So when you close your bracket, this is easily what you get. Very, very direct. So before we go wrap up for today, there's just one more side topic we would like us dive into. That's because whenever we discuss factorization of binomials, we dey also move into this topic, and it will also help in dealing with other topics which I will not mention for now. And that part na equivalent fractions. Equivalent fractions. Equivalent comes from the word equal. Equal. So when two fractions dey equivalent, they kind of equal, which means from one part you fit get the other part. So that's just what it means for maths like that. So if something dey equivalent to another, which means from this one you fit get the other one. So if I give you this one, then by yourself you fit find this other one. That's just how it works. And for it to form equivalent fraction, you just multiply wetin they call for English numerator and denominator by the same value. This just means say you multiply the upper part of the fraction and the down part of the fraction by the same thing. Make I explain inside the talk. So for example, if you get 2 over 3 and you want make equivalent fraction, you fit multiply this up, wey they call numerator, the upper part, and this down, denominator, the lower part, by the same thing. We could choose, for example, 5. So when you multiply this one by 5, you must also multiply the down by 5. So you get 2 times 5 all over 3 times 5. This will give you 2 times 5, 10 over 3 times 5, 15. Now, make I quickly tell you why they call am equivalent fraction. They call am equivalent fraction because if they do what they call taking to the lowest fraction, or taking to the simple fraction possible, the simplest fraction possible. If I divide this one, cut am till I cut am reach down, I will come to this number 2 over 3. For example, if I say 5 here 1, 5 here, I will get 2 over 3. That's why they say that equivalent fraction. Now this will be the main part. The main part is where they will give you a particular number and then go ask you to find the equivalent. Equivalent don't only work for multiplication, it works for division as well. Now look at example of division parts. Let's say you get 16 over 8. 16 over 8, if you want make am into equivalent fraction, wetin if you divide 16 by any number you can choose. Okay, let's say we are choosing 4, so you divide 16 by 4 all over 8 divided by 4. 16 divided by 4 is 4, all over 8 divided by 4 is 2. These two dey equivalent because when you divide them, you dey get this. Now, we could dive into the question itself. These numbers wey I use now, because we dey deal with algebra, I fit also add some letters to make it a little bit simpler. So let's imagine we get 3a over 5 equals to, we can't get box for here over 10. So when you get something like this, you no need to worry much. The process is very, very easy. Look for the one way they don't give you already. Take find the one way they no give you. And they go talk say now wetin person get, if they take find wetin he wants. So now wetin you get for here, you go take find wetin you want. Because na this box you want. So it is easy. You get 5 here, you get 10 here. Ask yourself question. This can be either multiplication or division, no two ways about it. So either they times am or they divide am. Ask yourself, how 5 take turn to 10? Wetin I fit do to 5 wey fit make am 10? I fit multiply 5 by 2 and it will become 10, and that's what they do for here. So that's what they do for here. Like I talked before, you do am for up too. If you born twins, whatever you give Taye, you must give Kehinde. Na general law for mathematics. Mathematics, you don't just do things to just one part of the equation. No, whatever you do to this part, you must also do to the other part too. So the same thing here, whatever you are doing here, you must also do to the one that is up. So for them to get 10 here, what do? They multiply by 2. Or 5 times 2 now 10. So you also do the same thing here. You multiply this by 2 in a rough paper. So you just get 3a multiplied by 2. That will give you what? 3 times 2, 6. Then you get your a. So here will become 6a. Very, very simple logic. Now we'll look at another one. If you get 8h over 5 multiplied by equal to 40h squared all over box. Now you get 8h, you get 40h squared. So wetin happen for here? How 8h take become 40h squared should be the question on your mind. Because if you go fit solve this one, whatever you take get this one, apply am for here, and you go get this one too. So that's the first question we are going to answer. How 8h they become 40h squared? When you have questions like this, when you solve questions in algebra, don't be in a rush. No rush too much to move into the answer. Look at the number part first. So when we look at the number part first, how 8 they become 40? What do we fit do to 8 to make am 40? We fit multiply 8 by 5. 8 times 5 now 40. So we have our answer on the number end. How did they get 40? How did they get h squared? There was only one h. To get the other h, multiply am by another h. So when you add h for here, you go get this. So which means 8h times 5h will give us the thing. 8 times 5, 40. H times h squared. So the only thing they do here, now to multiply whatever they here by this. If you do the same thing for here, you will get the down part too. So you get 5 times 5. That will give you 25. Then h times h. Oh, sorry, h no dey for here. So you don't get h for here. So you just pick this other h. You get 5 times 5h. So this will give you 5 times 5, 25. Then maybe one divisible 1 times h, or just put the h put there, and this will give you 25h. The same thing will work for division too. We're not going to look for question we will solve for the first part. No, we'll just use this one. So you get 40h squared over 25h equals to, they don't put anything for here, and then put over 5 for here. How you will take get the upper part? Very easy. Think of how they take get this one. First of all, 25 dey for here. 25 get h, but all of a sudden it become 5. H no dey for there. How they take get am? Simply then divide this 25 by something. So wetin if you divide 25 by? We go give you 5. If you divide 25 by 5, what about the h? What if you divide h by? Wey be say e no go give you anything again. If you divide h by h over h go cancel h. If I decide to write am fully, 25h over 5, wetin go give me? 5 here, 5h. 5 here, 1. 5 here go give me 5. H go cancel h. So wetin dem do na to divide this one by 5h. Because if you divide by 5h, na only 5 you go get. Make I explain that concept again. You just need to ask yourself, wetin if you divide this term by, wey go give you this one? Because na division na dem fit do for here. You cannot move from a bigger number to a smaller number if it weren't division in terms of equivalent fraction. So just dey easy. Multiply this one 25 by, starting with the number, this na 5. Wetin if you divide h by, wey go give you nothing? Na h divided by h, because e go cancel themselves. So if you divide this one by h, which means na 5h na dem use here. So this divided by 5h gave you this. So the same thing to divide this one by 5h. So you get 40h squared divided by 5h. We get, say this one na 2. So this 2 fit just cancel this one. Then 5 here 1, 5 here 8. So you get 8h. If I decide to open this one, this na 40 times h over 5h. 5 here 1, 5 here 8. This h cancel this h. Remember one h here, which is 8h. So this place will be 8h. The same thing we did for you, and the same thing we did for you. That was the part of equivalent fraction. So now we don't learn factorization of binomial, we don't learn expansion of binomial. The main reason why we learn those two first na because we wan learn how to work or simplify fractions. Because most times when you solve questions for maybe objective part of WAEC, they tell you say simplify, and they give you one long fraction, they get h for down, get b for up, plus divided by open bracket and so on. So this rule now we go use to solve how we go to simplify fractions. Till then, see you next week.